Hey, welcome to today's lesson. We got a lesson today on finding equivalent expressions, specifically combining like terms. So with that, we have some new vocabulary we need to go through. I've already filled it in for you, so I just need you to follow along and try to listen and make some sense of it. The first thing we need to know is, what is a term? A term happens to be a part of an expression that are separated by addition or subtraction symbols. So I'm going to write an example here for you. If we have 3x plus 5, we happen to have two terms there. We've got the 3x and we have the 5. It's separated by this addition symbol, so I happen to have two terms here. If I were to add a third term here, if I were to maybe say plus 4x, now I would have three terms. This would be one term, a second term, and a third term here. So that's what a term is. It's just each different part of an expression. So moving on to the next one, like terms are terms that happen to be alike. Terms that have identical variable parts that are raised to the same power. So here I have an x. When it's just x, it's the same thing as x to the first power. And here I have an x to the first power. And here I don't have any variable. So in this expression here, this 3x and this 4x would be considered like terms. So they have to have identical variable parts. If this would have been an x squared, this would not have been a like term because x squared and x are not the same thing. So then we move down here, a coefficient. We know from Greek and Latin, means with. So what is the number that's with your variable? That's your coefficient. So the number part of a term, the 3 would be the coefficient for this term. On this term, the 4 would be the coefficient. So it's the number part of a term, including the variable. And then a constant is just a term that doesn't have a variable. So here, 5 would be considered a constant. There's no variable attached to it, so it's not a coefficient. It's considered a constant. Good job. Let's keep moving on. Here we go. We have our same things. It's just written out in sentence form. So in an expression, terms are separated by addition and subtraction symbols. You can use the distributive property to combine like terms. Like terms have identical variable parts raised to the same power. And in a term, the number multiplied by the variable is the coefficient of the variable, and the term that has no variable is the constant. So again, we have another example here. We've got 4x plus 8x plus 1. 4x and 8x would be considered like terms. They both have x's to the first power. The coefficients would be 4 and 8. The constant is 1. So another diagram to help us figure out those vocabulary words. Here we have a way to show it visually, how we would combine like terms. If we have this expression right up here, we've got 2x plus 5 plus 4x plus 2. We can show that down here. The green rectangles represent x's. All of the yellow squares are just a single number, a number 1. So here we have 2 x's plus 5 1's plus 4 x's plus 2 1's. The first thing we want to do is rearrange these tiles. Remember, we've learned the commutative property, and that allows us to rearrange addition problems. So I'm going to rearrange it and put all of my x's together. I've got my 2 x's plus another 4 x's, and then I've got my numbers together. I've got 5 plus 2. And when I go further with that, when I go to evaluate it, I can see these are the same thing, so I can combine them together. 2 x's plus another 4 x's gives me a total of 6 x's. When I have 5 plus 2, I end up with a total of 7. So therefore, my original expression, 2x plus 5 plus 4x plus 2, can be evaluated or simplified down to 6x plus 7. We can do the same thing with subtraction. It's just a little bit different. Here I have 5x plus 3 minus 2x minus 1. So I have my 5x's and I have my 3. And then I need to take away, instead of adding more, I need to take them away. So I'm going to take 2 of these x's and get rid of them, and 1 of these numbers and get rid of it. So my simplifying is just by taking away. I'm left, after I take away that 2x and the 1, I'm left with 3x plus 2. So my expression 5x plus 3 minus 2x minus 1, when I evaluate it, when I combine my like terms, I put all of the x's together, all of the numbers together, I'm left with 3x plus 2. All right, so again, we could draw our tiles here. I don't have tiles for my video here. We have some in class to use that you're welcome to use at any point in time. But instead of drawing out rectangles, I'm just literally going to use x's. So if I have 3 x's, I have x, 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 3 x's, and then I have 2 more x's. All together, because they are all just x's to the first power, when I combine them all together, I end up with 5 x's. So this one can be evaluated to equal 5x. 3x plus 2x is the same thing as having 5x. Here, when I have 9x, I have 1, 2, 3, 4, 5, 6, 7, 8, 9x. And I need to take away 7 of them. That means I'm going to take 7 of them and get rid of it. I'm left with 2 x's. And last but not least, over here I have a constant thrown in. We'll have to see how that changes things. I have my 6, and then I have 3 x's, and then I have 4 x's. These are all x to the first power, so I can go ahead and combine these to equal a total of 7 x's. I don't have anything to combine my 6 with, so that just has to stay there. 6 plus 7x is my answer. I'm going to leave these blank, and we're going to look at these tomorrow in class, so you need to do these tonight to get a little practice combining like terms here. We're going to move on to the next slide. Here, now they don't want us to use algebra tiles. Let's see if we can do it without drawing it out. So the first thing I need to do is recognize, do I have any like terms? I have a constant and a term and a term. Both of these terms have a to the first power in it. That means they are like terms and I can combine them. This is going to stay as is because there's nothing to combine it with. So I have 4, and then when I combine 6 a's and 5 a's, I have a total of 11 a's. How about here? I have 10x plus 8y plus 3x. I have 3 terms. This one has an x to the first power. This one has a y to the first power, so those aren't the same. And here's an x to the first power. So I can take the 3 and the 10x and combine them. When I have 10x plus 3x, I end up with 13x. And then my 8y isn't going to change because I have nothing to combine it with. Over here, I've got an 1/2 m plus 3n minus 1n plus 2.5 m. Yowzer. I got a lot going on. I have 4 different terms, but this one is an m to the first power, n to the first power, n to the first power, m to the first power. So I can combine this box with this box. So I have 1/2 m and 2.5 m's for a grand total of 3 m's. And then I happen to have, I'm going to change my color here so we can see the difference. I have 3n minus 1n. So if I have 3 n's and I take away 1, I still have 2 n's. So 3m plus 2n. All right, this one is a super challenge one. You're going to have to use your distributive property and order of operations here. I'm going to ask you to try and attempt this on your own, and tomorrow we are going to look at it in class. So there you have it, combining like terms. They need to be exactly alike if you're going to combine them to simplify them. So look through and see if you can identify what like terms there are and see how much simplifying you can do. We'll see you tomorrow in class. Have a great night.